Welcome to everyone for attending this Connect session. My name is Bin Lee. I am the product manager for Couchbase query and indexing service. In today's session, I plan to cover the topic of migration from Oracle to Couchbase. This topic was chosen because we see quite a bit of interest from our fields team, from customers, prospects who are either on RDBMS or Oracle. And Couchbase 7 scope and collection will make it a lot simpler for these customers to migrate to Couchbase NoSQL database. But there are more to migrating Oracle tables to Couchbase collection because Couchbase is first and foremost a JSON document database, which means customer can leverage Couchbase document model to get the extra edge on query performance, while at the same time rely on the Couchbase NoSQL query language and its ability to perform SQL join and RDBMS people that have accustomed to. I also want to socialize everybody about our what we have from Couchbase that help you to cover this process. And lastly, I want to highlight a couple of areas that you will need to prepare to and decision that you need to make during the schema and data migration. So for our agenda, first I will cover the Couchbase legacy modernization materials, then review the lift and shift process, walk through the process on how to migrate to Couchbase collection, and then I review the two main migration strategy, which is the simple table to collections, and then the refactoring of the relational model. And lastly, I would talk about a technique that you can use to perform this Oracle to Couchbase migration using just Couchbase NoSQL. So at Couchbase, we provide everything that you need to migrate from RDBMS to Couchbase. We have made available to you a white paper on this topic, a webinar with a demo, a JSON data modeling guide. There's several blogs from our developers, advocates, engineers, and including one from myself that provide you with a step-by-step guide on how to migrate an Oracle database to Couchbase. In addition, we also have partners with Infosys, CData, Talent, and Irwin, who can provide you a full set of services to review your enterprise application needs, as well as tooling such as CData Sync Irwin to quickly migrate your data model from RDBMS to Couchbase. This process focuses on three main areas: lift and shift your data and indexes, shift your query and application, then refactoring your data model. The lift and shift data and index is very straightforward, as you can see. If you only plan to migrate your table to Couchbase collection on a one-on-one basis. But for the shift query, Couchbase NoSQL is basically based on SQL. And so Oracle SQL statement that you have should work directly with Couchbase. From the application or SDK perspective, we'll provide a wide range of SDK, like Java, Python, Node, and many more. And after you have successfully lift and shift your schema data into a Couchbase database, you can then consider refactoring your data model to take full advantage of the document model. This refactoring data model is by far the most important part and will require your decisions. So to illustrate the lift and shift process, I will use an example RDBMS schema here. This is based on a common component of many enterprise CRM systems, and that is the activity management database schema. The schema tracks all activity in sales, services, and marketing system. The key entity in this schema is the activity. So an activity can be associated to an account, i.e. activities such as a meeting or task are created for a given account or customer. 2, an activity can also have multiple contacts. In the case of an activity that represents an appointment or meeting, these are the account customer who attended the meeting. And this schema also supports multiple relationships between objects. For instance, an activity has an owner-user as well as owner-participant, as well as user-participant, i.e. those users who attended the appointment or meetings. I chose this schema because it is relatively comprehensive and with all the complex schema relationship, i.e. multiple parent and child, many-to-many, as well as self-referenced relationship. This RDBMS schema can be migrated to Couchbase as a table collection, automatically with many third-party tools or manually with Couchbase import. Note that the document model is much better at handling polymorphic objects, as in the case of the activity object, where it can represent either a meeting or a task. In contrast with RDBMS model, where the schema is rigid, the only way to ensure that the activity object can represent both meeting and task is to include all attributes from both types. You also note that the relationships are implied here in the document model because the document model is flexible and it does not enforce referential integrity. The next step in the schema data migration is to be aware of the data type mappings. Couchbase is a JSON database. As such, whatever is supported in the JSON standard is supported by Couchbase. From the RDBMS perspective, the standard varchar is treated as JSON string. As for all RDBMS numeric data types such as integers, float, decimal, etc., are all going to be represented as JSON number. For the date field, Couchbase will accept this field as string. Then we have date function to allow the application to manipulate the date and timestamp fields, whether they are stored in Unix timestamp or ISO standard. For CLOB and BLOB, you can use the binary format to store the document. But as you can see, there aren't many decisions that you need to make for your RDBMS data type mapping to Couchbase. And in fact, the Couchbase import tool can perform this mapping automatically during the import. It does this by looking at each value and decide whether it is a string or a number. Then use the infer type for the document. For other JSON-specific types, such as objects and array, these will not be used if you simply migrate or import your RDBMS data into Couchbase. However, they can be used if you are able to construct your exported data in a JSON format, which is supported by most RDBMS today. The next area would concern you would be the database constraint, specifically the primary key and foreign key constraint. Here, every Couchbase document has a key. The Couchbase starts with a key as a key value database. The key needs to be specified during the insert. The operation will fail if the provided key is not unique for the collection. You can construct the key string in any way you like, so long as it is less than 250 byte string. As you can see from the above Couchbase collection data model, there are no solid lines between these collections. That means there are no explicit settings for foreign key relationship. This flexible schema provides many advantages over the more rigid RDBMS schema. Flexible schema allows documents in each collection to be the same or completely different from each other, allowing the data model to evolve rapidly with the business requirement. Flexible schema, which is the basis for the document model database, is one of the key reasons for the uptake of NoSQL databases in recent years. Anyway, back to the Couchbase document model. Note that the document key is a separate part of the document, and it is used for key value operation as in the above SDK example. Worth mentioning here is that Couchbase secondary index is used mainly for query performance. And so whatever Oracle query index you have, they can be used with Couchbase index. So when you're ready to perform the migration, you can use any of our partners tools, as I mentioned, like CData, Irwin Talent, and many more and more extensive services from Infosys and Irwin, who can guide you through the complete process. In the above screenshot, you can use the Couchbase workbench to perform the document import from either a CSV or JSON file. You can then decide the target collection where the data will be imported to. Note that the UI also generates the command line in case you want to run the import in a script to deal with multiple imports or increase the number of client threads for each import to achieve higher throughput. All in all, it is a fairly straightforward process. Now let's talk about data access. After loading your data into Couchbase collection, you can use your existing SQL to query the Couchbase cluster. And if your existing database DML statements are standard ANSI, then they should work with the Couchbase collection. The example shows simple CRUD operation here. And as you can see, the NoSQL statements are identical to that of your RDBMS SQL statement. Notice that Couchbase has full support for join, inner joins, outer joins. As the result, you can migrate your RDBMS table as is into individual Couchbase collection. By the way, Couchbase also supports cost-based optimization. And so the join will automatically use a hash join if there is a benefit to do so. We do have a separate Connect session given by Bing Gmail on this topic. So do attend that if you would like to get more detail on the inner working of the Couchbase CBO on JSON database. The one statement that's clearly different is the insert. Here, you don't insert one field at a time, but the entire content of your RDBMS record as a single JSON document. As the result, the NoSQL insert only consists of two fields, the key and the value being the entire JSON document. Update and delete is identical to RDBMS SQL. But with the additional ability to remove a field altogether from the document with the unset command. In addition to NoSQL, you can also use Couchbase key value operation. This is a set of very fast API, and all KV operation require the document key. These API are available in numerous SDK, Java, Python, Node, as I mentioned earlier. So for the next session, I will cover the refactoring of the data model. So let's examine why you would want to consider refactoring your RDBMS data model. The relational model was invented by the IBM researcher E.F. Codd and are still in use today in relational databases. While the design is great at maintaining data consistency through the normalization process, it relies on the database join to retrieve related information. The join is dictated by the nature of the data, i.e., a business contact in this model is associated to an account, which is the term for business organization in CRM. So you need to join from contact to account to see the account information for contact. The model does not favor one access pattern over another. For instance, to retrieve all of the contacts who had attended an activity would require 3 entity joins. The activity entity must join to the activity contact, and then another join to the contact entity. And similarly, another 3 entity join to get all of the activities that a contact had attended. But what if your application access pattern always calls for the account information in each contact? Here you can do that by re-adding the account information to the contact entity in this model. But what about having all of the contacts who had attended in the activity added to the activity entity? The RDBMS model cannot support this because the number of contacts may be different from one activity to another, or predefining all of the columns needed to capture, say, a fixed number of contacts in the activity entity can also cause storage and processing challenges later on. Relational model was simply not designed to capture child object in the parent entity in this way. But that is where the document model in Couchbase JSON database comes in. Not only Couchbase document model allows you to capture these 2 types of optimization neatly, it also supports relational join, so you can get the best of both worlds. So the first part of the data model refactoring is the denormalization of the parent detail into the child object. In this case, we have added 1, the owner, user, and the account into the activity as a JSON object. Notice the curly bracket. And 2, the territory detail has also been added to the account object. Then 3, the account detail has been added to the contact. Notice that since territory has been denormed into account, territory also get copied into contact as a nested object as part of the account. We denormalize parent into child object to benefit from faster access, i.e. without the need to look up the parent information through join. As I have noted previously, some of the tools like Irwin is working on this type of denormalization automatically, but it does require configuration setting of how many level up you want to have. For instance, as denoted in point 4, for 1 level up, you can add the account detail into activity. For 2 levels, you can also have the territory of the account nested in the account object. So take a look at the post-denorm document. Here I'm showing 2 pieces of information. The parent account in red and parent owner user in blue have been added to the activity objects. Note that I only added the ID and names fields of the parents into the child activity. And here is a good example why the automated denormalization process may not work out well. Because how do you decide what parent field to add to the child object? It just does not make sense that you can do this arbitrarily. In my opinion, the decision should be based on the following. 1, the query access pattern, i.e. when you access the activity object, do you also have the need for the parent account's name or the owner user? For us, we understand the application requirement, and therefore we say, yeah, let's do that. But also the second point is, what are the parent fields that you need? Is it just ID or name or other fields? This should be based on the access pattern, i.e. your application, which could dictate by effectively the application UI. 3, how many levels do you need? Is it just the owner, username? What about the related experience, skill set, manager information? And finally, what about the cost of update? You will need to maintain this information both in the object as well as any of the fields that have been copied out of the activity object. The second part of the data model refactoring is the merging of the child object into its parent. In this example, an activity has several attending contacts. And so we have decided to merge the contact detail as a JSON array into the activity object. Again, notice the square bracket JSON notation here. There are also several of this type of merge in this model. 1, the contact who attended the activity are added to the parent activity. And then 2, user participants are also added to the parent activity. An important point to note here is that we have made conscious decision to optimize this data model to allow a single read of an activity to also include all contacts. However, the opposite is not optimized, i.e. it would require several reads and join to get all of the activities where a contact had attended. So this type of optimization must be carried out based on the application needs. As I have noted previously, some of the migration tools from our partners plan to perform this type of merge automatically, but this is not a simple process. So take a look at the post-merge document. Here I'm showing 2 pieces of information. All of the contacts have attended. An activity has been added to the JSON array into the activity object. And secondly, I have decided to add all contact detail field except the account into the parent activity. And here again, the automated merging process may not work out well. How do you decide what child field to add to the parent object? Notice that the contact account information is not copied over because it would be redundant as the account has already been included in the parent activity. In addition, the merging process must consider the overall object size. If there are too many child objects, i.e. if the number of contacts are unbounded, it would not be efficient to read the activity object. On top of that, there's also a physical limitation of document size, which in the case of Couchbase would be 20 megabytes. Understanding the business model of this schema, it would be safe for us to perform the merge of the child object into the parent this way. But nevertheless, we still need to make some additional decision. One, what about the child object field that you need? How many levels do you need? What about the cost of update? So overall, you need to be aware of the implication of these decisions. So let's talk about data access of the model after the merge. Notice that the difference between the pre and post merge. All of the many-to-many yellow objects have been eliminated. They are not needed anymore. This is because in the case of activity contact, you only need to perform a single read in the activity to get all of the account contacts who attended the activity. Likewise, a single read to get all the participated users in the activity. And take a look at the SQL, or in this case NiCO, that was used in the relational model. For the document model, you no longer need to join to get to the contact, as that information is already embedded in the activity. You do, however, need to use the unnest to flatten the contact array so that it can be displayed individually for the query. So NiCO also has extensive support for JSON arrays, such as the array operator and array predicates, which allow you to directly inspect the array without performing the unnest. Now I'm going to briefly review the process where you can use just Couchbase NiCO to perform Oracle to Couchbase migration. You can use this for one-to-one table collection or model the refactoring in one go. So to do this, you need to have access to a Couchbase cluster where you need to enable the curl function because we will use this in the NiCO statement. You also need to be able to connect to your Oracle server where you have to enable the Oracle REST data service. This is achieved by executing a store procedure in the ORDS package to enable the schema for REST access. Then in your Couchbase workbench, you can run a query to read from the Oracle server and insert the result directly into the Couchbase collection. So let's take a look at this statement. One, it is an insert select construct, which is a standard DML construct. Two, the insert, as I have shown previously, insert the entire document ndoc in the value field. Three, the select statement reads from the curl function as a table expression. Four, the curl function issues a post request to the Oracle REST data service. 5, it passes an Oracle statement to the REST service. Notice that this is Oracle SQL statement is trying to get the activity with the activity owner. So it has a join between activity to user table. 6, the result of the curl function is captured in a single object denoted by the R alias. After getting the result back, we then use the NiCO unnest to get all of the Oracle rows result, which are packed in the items array. I hope you are able to see what the insert select does, but essentially you can read directly from Oracle and insert into Couchbase collection. There are no third-party tools involved in this technique other than what's available from Oracle and Couchbase. This is a great way to get your data into Couchbase quickly, and you have full control of how your document will look like in Couchbase. You can also perform all of the data modeling refactoring, as I have discussed in this session using this technique. I have the blog, how to use just NiCO to migrate from Oracle to Couchbase, which would go into much more detail on this. So let's have a recap of the migration process. You can migrate your Oracle table directly into Couchbase collection. This is relatively simple, which can either be accomplished with a third-party tools or manually with a Couchbase import. With tables and collection process, all your SQL statement and your index definition can be used in Couchbase without modification. Or you can include the refactoring process to transform your relational model to the document model, where you can optimize your data model by reviewing your application access pattern. This is more involved process that you would involve in data architect and developers. Your existing SQL statement and index will also need to be modified to reflect the new document model. But what if you decide to leave the refactoring step out of this process? You can still benefit from many features, some of which are unique to Couchbase. A distributed database platform that offers high availability built in at every layer when you configure your data and indexes with Replica. And multi-dimensional scaling, which means you can scale out in any way you like, or just the specific service that you need, whether it is querying, index, full text search, analytics, or eventing. But that is from a DBA perspective. From a developer perspective, you would have a SQL language with integrated search capability. Oracle does provide its own text search which contains Constraint, but anything more advanced, then you need to use a dedicated search engine like Elasticsearch, which means different API. Whereas NoSQL search function integrates Couchbase text search into the query language, so you use the same API on the same database. Then we have a more advanced flex index capability, where NoSQL can be given a hint to use a text search index if one is available, or the standard secondary index for your query. All this with just the standard SQL predicate construct. This means you can leverage the flex index feature without modifying your Oracle SQL statement in your application. On top of all this, Couchbase Query also supports all of the functionality that you would come to expect from an enterprise-level NoSQL database, such as transactions, rule-based, cost-based optimization. And if you are unsure of what kind of index you need, especially in the world of document model database, we have Index Advisor. And also advanced Windows analytical function to increase query efficiency for data window analysis, which otherwise would require more post-processing like in Excel, etc. So that's pretty much the end of this session. So thank you for attending.